So today we will be learning about resonance pendulum, how we are going to use a resonance pendulum to calculate the value of G. The aim of the experiment is to determine the equivalent length of Cater's pendulum and hence determine the acceleration due to gravity at that place. Okay. The apparatus that we are going to use is Cater's pendulum, simple pendulum, telescope, stopwatch and meter scale. So this is a Cater's pendulum. Cater's pendulum is a long metallic rod. Okay, you can see this metallic rod. It is around 1.5 meters long. It has got two knife edges here, one on each end. There are two big cylinders and there are two small cylinders. There is one big metal cylinder and one small metal cylinder. There is another big wooden cylinder and a small wooden cylinder. Okay, as we change the position of all of these things, we see that the time period of oscillation will change. So even if you move any of these metal masses, you see that the time period changes. Due to this metal mass, since it is a cylinder, when it is oscillating, it produces an air resistance, right? This wooden mass is used just to cancel out that air resistance. There are screws on all of these parts. It can be moved anywhere on the entire length of Cater's pendulum. Now, when you are using Cater's pendulum, there are certain things that you have to be very careful about. Okay, so whenever you are suspending a Cater's pendulum, you should be sure that the knife edge is resting on this glass plate. These are the hands of this support. At the same time, you have to be careful that this rod of Cater's pendulum is not touching these arms of my support. Okay, why are we being so concerned about all these things? Because it is an oscillation experiment. Here we are putting it on a glass plate because so that the friction is very less. At the same time, if this rod is touching any of the hands of the support, then that means it will also cause friction, because of which my pendulum will slow down. So that there is no resistance to my pendulum, I have to be extremely careful about all the setup every time when I am taking the reading. Now let's start with the procedure. We are going to suspend a simple pendulum of length approximately 45 centimeter from the screw of any cylindrical attachment of the Cater's pendulum, which is closer to the point of suspension. Whichever cylinder is closer to the point where I am suspending the Cater's pendulum, I will be attaching it to the screw of that particular cylinder. Arrange a meter scale directly behind the bob of the pendulum so that the amplitude of the simple pendulum can be observed. We will be using a stand. We will be fixing our meter scale on this stand, and this meter scale should be behind the simple pendulum but in front of the Cater's pendulum. This meter scale should be parallel to the ground. So if you look closely from the side view, the picture will look something like this. See, the third point of procedure is give an initial amplitude of 2 centimeters to Cater's pendulum. Because of this 2 centimeter displacement given, my Cater's pendulum will start oscillating. But what is going to happen is, as soon as my Cater's pendulum starts moving, I see that my simple pendulum also starts moving. So you will see that my simple pendulum is oscillating and slowly its amplitude is increasing. At one point you will see that it reaches its maximum amplitude and the amplitude starts reducing. Okay, so what we have to observe is this maximum amplitude. So whatever is the maximum amplitude, I have to note it down. I have to repeat the same step of giving 2 centimeter oscillation to Cater's pendulum and calculating the maximum amplitude of simple pendulum. Step has to be repeated 5 to 6 times for different lengths. So you can increase the length in the steps of 5 centimeters. So 45, 50, 55, 60, 65, 70. ऐसा करके 120 centimeter तक length of the simple pendulum you can go. Okay. Only thing that you have to calculate is, first of all, you have to note down the length of your pendulum. At the same time, you have to note down the maximum amplitude with which my simple pendulum is oscillating. I told you this experiment is extremely simple. The only thing is you have to be very careful about how you are setting it up and how you are performing the oscillation. So there are few steps that you have to remember. First thing is, make sure that the thread, bob or the Cater's pendulum is not touching the scale or wall. Cater's pendulum should not be touching the handle from which it is suspended. It should not be touching the wall also. Okay. Similarly, the simple pendulum, it should not be touching the Cater's pendulum. It should not be touching the meter scale which I have placed. Okay. There should be good amount of distance between all of them, at least 1 to 2 centimeter distance between all of them. The second point is both the Caterer's pendulum and the simple pendulum should be at rest. Simple pendulum should not be oscillating when you are giving a displacement of 2 centimeter. Okay, so first you have to bring both the pendulum to rest and only then give 2 centimeter displacement to the Caterer's pendulum. The third one is, according to the procedure, we have to look at the simple pendulum and the amplitude of the simple pendulum through a telescope. So even if we perform this experiment without the help of telescope, it is totally fine. So if you are looking at the pendulum by yourself without using a telescope, the simple pendulum and the scale and the Caterer's pendulum should be in a straight line like this. Only then you will get a correct reading. And the fourth thing that you have to remember is, when I'm increasing the length of the simple pendulum, every time you have to shift the scales. Okay, so it is something like this. So if you have a simple pendulum oscillating like this, here, can you tell me what is the maximum amplitude that you are getting if you are looking at the lower scale? 21.5. ठीक है, चलो ये एक मेरा फर्स्ट रीडिंग है, समझते हैं हम लोग. ठीक है, अभी मैंने मेरा सिंपल पेंडुलम का लेंथ बढ़ाया, बट मैंने मेरा स्केल को शिफ्ट नहीं किया. अभी भी मैक्सिमम, अगर सेम पोजीशन में मैं अगर मैक्सिमम एम्पलीट्यूड ढूंढ रही हूँ, तो अभी भी एम्पलीट्यूड मेरे को 21.5 ही दिखा रहा है. सो दिस शुड नॉट हैपन. This is wrong. When you are increasing the length of the pendulum, you have to shift the scale down as well. Now when you look at the maximum amplitude, you see that the maximum amplitude is going up till 22.2. These are the 4 points that you have to remember. So this is the setup in our college, which I had taken a video of. You can see that before putting it into oscillation, both Caterer's pendulum, the bob is at rest. Okay, and then I am giving an amplitude of around 2 centimeter to Caterer's pendulum. देखा, simple pendulum अपने आप से हिलने लग रहा है, and you can see that the amplitude is increasing also. Correct? At one point it reaches maximum amplitude and then again its amplitude starts decreasing. At that time, notice the Caterer's pendulum. Caterer's pendulum का amplitude maximum है. फिर Caterer's pendulum जैसे ही slow होने लगता है, मेरा simple pendulum फिर से maximum amplitude से oscillate होने लगता है. First of all, I didn't set my simple pendulum in motion. मैंने सिर्फ मेरा Caterer's pendulum को amplitude दिया ताकि वो oscillate कर सके. पर मेरा Caterer's pendulum हिलते हिलते simple pendulums भी हिलने लगा. फिर एक पॉइंट पे जब simple pendulum का amplitude maximum हुआ, मेरा Caterer's pendulum almost stationary था. And then we saw that the amplitude of simple pendulum started reducing. At that time, Caterer's pendulum started moving faster, मतलब the amplitude was higher. Then my simple pendulum was almost at rest. At that time, my Caterer's pendulum was having maximum amplitude. Why? What is happening? Why is this happening? So one point is conservation of energy is happening. Is momentum getting conserved? Momentum has to remain constant. Okay. So because of all this, there is energy transfer happening. Momentum is getting conserved, and because of all this, my two pendulums are acting like this. Resonance happens when your natural frequency and the external frequency become same. Every wire has a natural frequency. So here my Caterer's pendulum is there and my simple pendulum is there. Okay. We have suspended our simple pendulum from our Caterer's pendulum, and I set Caterer's pendulum into motion. Now what is happening? I didn't touch my simple pendulum, but since simple pendulum is connected to my Caterer's pendulum is applying force on that string, and because of which my simple pendulum starts moving. Okay. Now when will my simple pendulum start resonating? When the external applied frequency is equal to its natural frequency. Because of the length of that simple pendulum, it has got a particular natural frequency of its own. Whenever this natural frequency becomes equal to the frequency with which my Caterer's pendulum is oscillating, at that particular point I'll get resonance. If I'm noting down all the maximum amplitudes, I will see that even in those maximum amplitude, there is one point where my amplitude was the biggest. उसके आगे अगर मैं लेंथ को इंक्रीज करूंगी तभी भी मेरा मैक्सिमम एम्पलीट्यूड रिड्यूस होता है. उससे ज़्यादा मैं लेंथ को डिक्रीज करेगा तो भी मेरा मैक्सिमम एम्पलीट्यूड रिड्यूस होता है. Okay, so here if you are looking at the top wala reading, towards the left side it is 6, so 68 पे मेरा simple pendulum है, 69 and 70. Okay, so this is my mean position. If I want to calculate the amplitude, I'll always calculate amplitude from my mean position. हाँ, अभी सपोज जब ये स्विंग कर रहा था, यहाँ से मेरा पेंडुलम स्विंग हो के मैक्सिमम एम्पलीट्यूड 6, सो अराउंड 60.5 पे मेरा मैक्सिमम एम्पलीट्यूड मिल रहा है. 68 minus 60.5 will give me my maximum amplitude. So in the observation table, we are writing down the length of the pendulum, the maximum amplitude. For every single length, we will be calculating maximum amplitude twice. Calculate the mean amplitude. By the way, I had told you that we will start the reading from 45 centimeter and in steps of 5. But if you look at the values of length, you can see that it is 48, it is 54.5, 60.5. So the lengths are like this because it is hard to unwind the thread in such a way that we get exact multiples of 5. Okay, so unwind the thread, measure the length of the thread from the top surface of the bob. Again, this is a point that many people do wrong. Okay, this is the kind of bob that we use, but when you are calculating the length, this is my bob, so you have to start measuring from the head of my sphere, not from the hook. Okay, please remember this. So the seventh step is I have to plot a graph of amplitude against length. Here you can see I have length and I have mean amplitude. I will be plotting a graph of A versus L. Resonating length is the length in which I am getting the maximum amplitude. Okay, after plotting the graph, I have to remove the simple pendulum from my Caterose pendulum and I have to calculate the time period for Caterose pendulum. Time required for one oscillation. We have to determine the radius of the bob of the simple pendulum using our vernier caliper and to calculate the equivalent length. Whenever we speak of simple pendulum, we consider a massless thread and a point mass. So if I am calculating the radius of that bob, so whatever length I am getting, I'll add my radius to it, so that I'm actually coming to my concept of massless thread and point mass. Okay, for that we have to calculate the radius of the bob as well. Okay, so and finally using the formula we have to calculate the value of G. Count of this vernier caliper is 0.01. So the zero error of vernier caliper is found to be 0. So the zero correction is also going to be 0. Now this is the main scale reading. Since the bob is of almost uniform, the main scale reading is going to be same in most of the cases. Okay, this is the vernier scale reading. Find out the total reading. So calculate the mean of these three readings. That is going to be your mean diameter. इसको डिवाइड बाई 2 करो, रेडियस मिल जाएगा. दिस इज द ऑब्जर्वेशन फॉर Caterose pendulum, टाइम पीरियड ऑफ Caterose pendulum. So time required for 20 oscillation is 32.2. When I divide it by 20, I get t is equal to 1.61 seconds. Let's look at the graph. We have to make a graph of A versus L. That means on y axis I will have A and on x axis I will have L. I can start from 0 in y axis, but on x axis I need not start from 0. I can start from 45 up till 80. I have to plot. Okay, so when I start plotting the point, I see that the point plot is something like this. It kind of gives me a bell-shaped curve. Okay, this is my maximum point, right? This is the length, this is the resonating length. Draw a perpendicular line down to my x-axis. Wherever it is intersecting my x-axis, it is going to be my resonating length LR. Okay, once you get the resonating length, you have to find the length of Caterose pendulum. Length of Caterose pendulum, which is equivalent length of Caterose pendulum, that is nothing but this resonance length along with the radius of the bob. Why are we adding the radius of the bob? Because we are considering our mass to be a point mass. The entire mass is concentrated at the center of the sphere. That means the length of this pendulum will be from the center of the sphere up till the screw. So 64 plus radius that we calculated 1.258 will give me 65.258, which is the length of Caterose pendulum LK. Okay, उसको फिर A वाला फॉर्मूला में डाल के हम लोग को फाइनल G का वैल्यू कैलकुलेट करना है.